Okay, hi everyone. Welcome to Always Coding, our weekly Hacky Hour. I'm Komal Devjani, a developer advocate with Always AI, and I'm here with Lila. Lila, are you available to introduce yourself?
Hi, yes, I'm Lila Mullaney. I'm also on the developer advocacy team. Yeah, nice to be here.
Thanks, Lila. So today's topic is focused on bounding box classes and distance measurements. So I'm going to start it off just by showing everyone how you can get started and just show you a simple app that Lila created. And then from there, I'll hand it over to Lila to get into the topic and talk about bounding box classes, what you can do with that, as well as distance measurement. So let's get started. I'm going to share my screen now. And let's go into Always AI. And as you can see, I'm already in my dashboard. Once you go onto alwaysai.co, you can just do /dashboard or go right into it by clicking dashboard. It's going to be on your top right-hand corner. And today we're not going to create a project using dashboard, but I just want to show you where you can download the CLI from, just so you have an idea of how you can get started. If you scroll down, you will see something called CLI install instructions, and you can follow the steps here. So click install and then pick your operating system. I'm obviously using Mac, but you can use a Windows or select a different operating system. Hit next, and it'll give you the option to download the latest CLI for the Mac OS. And one thing to keep in mind is we're frequently updating the CLI. So if you haven't downloaded it in a while or you haven't updated in a while, it's a good idea just to go ahead and update it so you have the latest version installed. Okay, with that out of the way, I'm going to show you how you're going to run a object detection classification app. So we're just going to go in here and copy this Git URL. So copy here, go into terminal, and I'm going to make this a little bit bigger so everyone can see. And I'm going to go into my Always AI directory. And then from here, what we're going to do is go into, actually, we're just going to git clone. So git clone, paste the URL. And I think that should be there. So let's see. And yep, I think I see it here. So object detection and classifier. So we're just going to go into it. Object detector and classifier. And then from here, I want to do AAI app configure. And as you can see, it gives me an option to create a new project. I actually took Steve's advice and went ahead and cleaned all the projects I wasn't using anymore. So it's all cleaned up. So I'm going to create a new project and let's call it bounding box. Okay, and with that, the project is created. We're going to save it on our local computer, and then we'll just follow the steps to go ahead and start the app. So we're going to do AAI app install. And then install, and then we're going to do AAI app start. And hopefully that's working. So let's just, and we're going to copy this streamer URL and go into a browser and paste that in. And as you can see, this is running this model here, but it's passing it through the age classifier. So sometimes it thinks I'm between 8 and 12 years old, and sometimes it's accurate between 25 and 32. But I just wanted to point out the interesting part of this app is that it's actually taking the bounding box from this model and detecting my face and passing it through the age classifier. So there's effectively two models being used with this app. Okay, and it still thinks I'm 8 to 12, but that's fine. And we're gonna stop right there. And Lila, I'm gonna hand it over to you to go more in depth with bounding box classes and distance measurement.
Thanks, Kamal. So yeah, we're doing bounding boxes today. And if you were with us for the annotation hacky hour, we went over how we annotate images with bounding boxes, where we're defining a region of an image that contains an object of interest and then assigning a label to it. So when we use object detection models, it's kind of the reverse. The model predicts an area of an image that contains that object, and that region is defined with the bounding box. So We also have in the EdgeIQ library an object bounding box class that represents that bounding box that the model returns when it makes its predictions. So let's see, I'm gonna share my screen. Oh, sorry, can you enable it? I always forget to ask.
Yeah, sorry about that. Okay, try now.
Perfect. Desktop one. Okay, nice. So the first thing I want to do is take you to the docs page at once you get to the Always AI website. So here is where you can find all the wonderful documentation on pretty much anything to do with Always AI. That's always a good starting point. But what we're going to do is go down to this EdgeIQ API and look at the bounding box class, which I have here. If you're familiar with object-oriented programming, you probably already use objects, and objects have attributes or properties that you can access that represent some sort of state or characteristic of the object. And they also have methods and functions that you can call using those objects. So not to get too into programming stuff today, but this is the kind of stuff we're going to be using. These attributes in the bounding box class are going to be really useful. So you can see they have start x, start y, end x, end y, and that's because the bounding box is really based on coordinates. In the image, you can think of it like a grid, and the important thing to note is that the origin of this grid is always in the upper left. So I'm going to actually do a new share. And if we have any questions, feel free to interrupt me. And if I'm not making any sense, please tell me. So in any image, you can think of this as an image. The coordinates are going to start from this corner and go this way. So when you have start x and start y, the start x, this is, your x coordinate is this guy, and y. Those start ones are going to be the ones upper and left, and then end are going to be down here. And later when we do the demo, I have some code that you can plot those points, make it a little easier to see what you're working with. But that's the general idea. And so when you have these bounding boxes in an image, they're really just marking that section of the frame, that image frame, with coordinates that correspond to the pixels in a way, because the image itself is an array, a NumPy array. So this is a little, I don't want to get too in the weeds, but it's important to kind of realize that at the core of everything, the images that are returned that you're using are NumPy arrays, and the bounding boxes are coordinates that you can then index into those arrays, and that's really useful. And we've abstracted away a lot of the complexity with that with these lovely EdgeIQ API functions, but it's always good to know what you're actually using when you're using these objects and the functions behind them. So that was kind of a brief intro to that. Are we doing okay? Do we have any questions or concerns?
I don't see any questions yet, but if anyone does have anything, feel free to raise your hand, or you can use the Q&A button as well.
Nice. Okay, so we'll go back to the library. So that's the basic start x, start y, end x, end y, and we're going to plot them later so you can kind of see what's going on. The width, pretty self-evidentary, is the width of the bounding box. Same with height. So you don't have to calculate it yourself with, x minus x or y minus y. It's already done, as well as the area, which would be the width times the height, and getting the center of the bounding box. So, you could do all this stuff yourself if you wanted to kind of dig in and get messy, but I personally don't like XY coordinates. They get a little dyslexic, and it's really handy to have these here. So we're going to use a lot of these in the first demo app that I have, which is actually a distance detector, and it uses this compute distance function, which gets the distance between two bounding boxes in terms of the NumPy array, not in terms of out here in the actual world. And then this get intersection and compute overlap, I'm not going to demo today because there's only so much, with one application, but this would be really handy if you're wanting to see when two bounding boxes line up, how much they line up, what is the region that they line up. Maybe you wanted to see if something is intersecting and just get the region that those two boxes line up. Maybe if, one person is in one and one person is another, you don't want both, but you just want the stuff in between. So those are really handy functions. And you can play around in this library, this documentation a little bit and see what more they have going on. But now I think if we're okay for questions, are we? Then I will do a demo app.
Actually, Steve suggested to show the docs page on the project page.
On the projects page. Oh, like working with projects?
Mm-hmm. Need to show the docs. Let me give Steve.
Am I like not sharing the right screen?
Steve, do you want to elaborate?
No, right now you have your project screen up, and so you're going through the different properties on the bounding box. So I was like, show people the thing. That's all, Lila. I'll be quiet now, but that was it.
It's my Safari windows. Thank you. Yeah, and as you can see, yeah, I was wondering why there wasn't the green box. I thought it was because I was sharing the whole desktop. Just the hazards of Zoom shares. Thank you. Okay, so these were the functions I was talking about: compute distance, get intersection, compute overlap. So we're going to see how all of these guys get used in a sample app. And so I think we're okay now. We don't have any other questions. Let's see, and I think let's do, sorry, I know it's
nope, no other questions right now.
Shares.
But AB did suggest that this API can help people if they want to make a social distancing app, which is a great idea.
What can? Sorry?
He said that we can use this API to build a social distancing app.
Yes, yeah, actually, that's kind of what we're going to do. I'm going to do it with a hand detection model, but you could have easily used people. I just thought that me sitting here demoing to you guys, I could have two hands, but it would be hard for me to get another person in the frame with me. But yes, absolutely, you could. And that would be very useful in this day and age. So everyone can see my console and stuff here, okay? Okay, and it's big enough. Let's see. I have already cloned these guys, but if you haven't, what you need to do is go to the alwaysAI GitHub, which I believe we have a link for. I can paste it in the chat if we need to.
I can share it.
Okay. And first one we're going to do here is the distance detector. So you get the URL just here as Kumal showed before, and then make your directory and do git clone that URL. I've already done it. So here's the project. And as you probably saw when I was sharing my projects page, I have a ton of projects. This one has already been configured to use a project that I set up before. But as Kamal showed, you can create a new project or use an existing project. Install. And you can see it's using the hand detection model. Okay. Okay. So here's, and you can kind of see it's an output in inches and centimeters. So the idea is that, okay, I'm getting closer to the screen and, it's changing a little bit. It's not the most like robust app, but it's staying around like 6 inches, even though it's getting closer. And then if they actually get farther away, so it's supposed to just actually show this distance between them. And I think my computer's having a hard time running Zoom and everything all at once. But that's it in terms of running and seeing how it does. Any questions on that so far, or should we dive into the actual code?
Yeah, I believe Avi has a question.
Yeah.
Hey, Avi.
Thanks, Lila. Nice demo. A quick question. This distance which you showed, 6 inches, right? Is it so when you measure it actually in actual? I believe you're not using any depth camera and all. You're just using a normal webcam, right?
Yep, it's the same camera that you guys are using, or that I'm using to use for Zoom.
Yeah. So, so my question is like, is that 6 inches is the actual distance as well? You measure it just to compare with the ground truth?
Yeah, I mean, it's kind of hard to measure my own hands, and then
I know.
but I did. Yeah, I tried to do like, you know, measure them lying down and then up. It's not going to be completely accurate, and of course, it kind of depends on my camera's ability to detect and, you know, how far away I am. So obviously, a depth camera is going to be much better, but it's pretty close. I mean, like, it's measuring from the center of each bounding box.
Yeah.
So it's about right.
No, my question is, I'm aware that that camera will give you. So did you, do you think if you calibrate your camera using the checkerboard or something, will the accuracy increase?
I would assume it would. I didn't.
Okay.
But yeah, and I know that cameras like the RealSense and everything can be calibrated. Maybe Steve has more insight into how you could configure or calibrate different cameras and how much the accuracy would improve. This was, you know, kind of
No, this was just a question I had because
yeah.
camera calibration is very important, and it is a very important topic, I think, when people work on any this kind of distance measurement on this kind of things. It's a very good topic actually. It's very difficult as well. Like I had a very hard time to configure a camera with a checkerboard, and we had to go to a lot of help. Like I had some help luckily, but it's a very good topic to there are some scripts as well, some available, but my question was, did you do that? That's why.
No. Yeah. No,
Because
I
you said
didn't.
it is accurate, right? So that's why that was my follow-up question.
Yeah, and I'm, you know, I bet it would be more accurate if I
Okay.
And maybe there's some programmatic stuff too that, you know, when I show the actual code, maybe if you have any insights into making it more accurate with the app itself, not just the configuring of the camera.
Sure.
But yeah, I didn't. That would be interesting if I could and see if it improves.
No, yeah. Okay, cool. Thank you.
Did Steve want to add anything to that, or should we?
No, but a couple other people did want to add something to that, AB.
Oh, yeah.
Helpful. Yeah, so Franco Vargas said that even if you calibrate the camera, you can't know the depth in reality. You can estimate based on a no line in the world, but the calibration with the checkerboard is used to remove camera distortion.
Interesting.
And then Philip said that it's only accurate if both hands are on the same plane and parallel to the camera view plane. Is that accurate, Lila?
I'm sorry, what?
He said that it's only accurate if both hands are on the same plane and parallel to the camera view plane.
Interesting. My app or in general?
I think this is in general.
In general, that's true.
Okay.
Yeah. So, I mean, a depth camera is going to take an image it sees out in front, and it's going to, you know, project it to the back, and then, you know, it needs to be in front of it, and then you have it's fairly accurate to do that. But yeah, he's correct on that. So
Cool.
Okay, yeah, we can continue.
Okay. Yeah, that's interesting. Yeah, I am not an expert in depth cameras or hardware configurations. That's very interesting. Okay, let's see. Distance. Let me open up. Oh, this is the project directory, just in case people are curious. These are the ones we're gonna take a look at. Okay. You guys see the Visual Studio okay?
Yeah.
Okay. So, oh, and I forgot, let's open up. this guy. Okay, so this is the main app.py. We have a configuration file that some of our other apps use. It's kind of handy. So I'll go over that in just a second. This just loads it. And I borrowed that from one of our other sample apps. This key items will be the items that we are aiming to detect. And those are defined in the config file, these interest items. So this is kind of roundabout. So I'm going to kind of do this instead of going through one file at a time, we'll just kind of follow the logic. And if it's confusing, please shout out. So these interest items are an item that I made that just have a width, a height, and then the name and the labels are just handy. So this is how I did it. I know the width and height of my own hand, and that's how I'm able to kind of map the pixels in the frame to the actual inches that my hand comprise. So I don't know how depth cameras work in particular. Like I haven't tried this with the RealSense yet, but that is how I'm able to do it without having multiple cameras. And so you can see here, the labels of interest are just hand, but let's say you're using a different model for object detection for people. Maybe you're using 2 different models. So there's person, maybe capital P or lowercase p. You can add in different labels here, or maybe you want to track multiple things in person, plant, car. You can add them in different interest items themselves. So the labels are just so that I know, the model knows that it should actually capture that. And then if there was like hand, capital H, lowercase h, or maybe a misspelling or something, and you were using different models, you could put all those different labels here. So these are in inches. I should make sure that that's clear. If you're using centimeters, you can just times it by 2.54 or whatever else you'd like. And then, whatever metric you're using, that's the metric you're going to get in the end. So we get those interest items. These are just the model that we're using. These are other aspects in the config file, hand detection. So then it's pretty similar to most of our other starter apps that we've done here. You get your object detection model, you're kind of printing out the labels and whatnot. Then here is where I am pulling out the config stuff and creating those interest item objects themselves from the config file. So it's just kind of setting all of that stuff up and storing them in this key items list. So you can iterate through it later and be like, okay, this list is full of interest item objects, and they'll have a width and a height, and that'll make it really easy for us to pull those out and use them in our distance calculation. And then the labels too, you go in their own list just to make it a little easier. And then really it's just starting up the webcam and looping through until we get an interrupt for closing out the project. This is in case you want to use multiple models. I've left this logic in here so that you can loop through all the models if you would like. They start them up here. And then if the prediction that gets back has a label that is in our interest labels, then we're going to mark it up. But you could also have maybe like another list of different objects. You can add in some different logic here. Maybe you only want to detect certain objects, but you don't want to find the distance between them all, something like that. You could put them for prediction and prediction. Otherwise, do something else. So I had this predictions to mark up that you could add more predictions to that aren't in this interest label logic here. It might be a little confusing, but I did it so that it would be a little bit more extensible for other use cases. And then what we're doing here is we're just marking up the bounding boxes. That's a pretty standard EdgeIQ object detection thing you guys have seen before, using these predictions that were returned. And then here's where the distance calculations come in. So that is over in this helpers.py. Are we doing okay for questions, or should I stop?
Yeah, we're still okay. No questions yet.
Okay, nice. So this draw distances function takes in the frame, the items of interest, and the predictions that came back from running that through our hand detection model. And so what we do, and you know, if you guys have any better ideas for the logic in here, you're welcome to make a pull request on that GitHub repository, because this was just out of my own brain. We loop through all the items in the prediction, and if they're in the key items list, we get the pixel scale. So this is where we used the area function from the EdgeIQ library. Let's see, I still have that here, this guy. So what it's doing is it's getting the area of the bounding box and dividing it. Well, first it's square rooting it, because the area would be whatever the unit is, like pixels squared. And it's dividing it by the square root of my hand's area. So item.get area, I have this function that just returns the width times the height. So in that sense, you're finding out how many of those NumPy array units map to a hand, in a sense. So it's units over inches. And then what we do is we calculate the distance by using that compute distance function, which is here. So that takes, you call it on a box. So like box dot compute distance other box. So you pass in the second box. So this is the first box looping through, and if they're not the same box, it's going to do this calculation, other box, get that distance, and then divide it by the scale. So you have, let's call them pixels, pixels over inches. So then you get inches. They're probably more like just NumPy units or whatever they are. But so now you're getting the actual inches that have mapped to the distance that was calculated by EdgeIQ. And then we're just drawing a line. This is OpenCV. We can import it up here. That is really handy for drawing stuff on your lovely NumPy arrays. So this is the same frame that was passed in. We're just marking it up. This is how we're finding the centers of those boxes with that other handy EdgeIQ function, center. So for each box, you can access its, well, it's not really a function. I keep saying function, I'm sorry. It's really more of like an attribute or property access. You're accessing the box center. And this is the X, and this is the Y. And then same thing with the other box. So we're drawing this is OpenCV's line function. So it's the image, starting point, stopping point, color, which we just defined up here. I picked green. It's in RGB, BGR, shoot. I always get it's not RGB, it's the flip of that is what it is. And then this is just the line width. And so if there was actually a distance that we found, then we're also gonna return this little text that says what that was in inches and in centimeters. And that is what we get back out here. And then we just update the streamer as we've done in all of our other sample apps. And that's about it. So that's how that was done. Really, it's just utilizing all those properties of the bounding box and a little bit of math just to map it to what I've measured in real life as a hand. So as long as, you know, for people, it might be a little more complicated because maybe you'd have to pick an average height or maybe some other, and so that would definitely impact the accuracy if you were doing every person the same, obviously, or even if you classified, like took that bounding box and passed it to another classifier to classify like men versus women or something that would maybe get you closer to an average height, but it would still be a pretty big difference. Are we doing okay for comments or questions?
Yeah, we're doing okay for questions. Steve just posted a GitHub to show how stereo cameras work. So if you're interested, you can check that out. But yeah, otherwise, I think we're okay to keep moving forward. I'm sorry, does anyone have any questions? We can take a pause.
And what I was going to say is what Lila's doing is actually what NASA does. So if you ever looked at the rover goes for something that they call they have a silver dollar on the rover, and they use that to figure out, they know how big it is, and they take a picture of that as they go into the rock, so they know how many pixels per inch or metric, what if they're using a metric, and they use that to figure out distances as they put that up next to it as the reference application. So this is pretty standard, and our good friends at NASA have used this and use it on the rover. So
good enough for NASA. It's good enough. For
yeah. So there we go for the non-stereo camera folks. That's how, like I said, that's an easy way to do it with a regular camera, and you want to know.
That's pretty cool.
Yeah, that's really interesting.
That's really cool.
We do have a question from David. He's asking, is there a finger pose capability associated with the hand detector process?
As far as I know, it is just a hand detection. It can detect that there is a hand, but it doesn't have any relational, in terms of the fingers themselves. No, I don't, and I don't think we have any.
Como, that's going to be not next week, but the week after that, Hacky Hour. So That's a good question. So tune in 2 weeks, and we will be going through that. So
nice. We still good? Should we move on?
Yep, we're good.
Cool. So in addition to all those lovely properties, which I sometimes refer to as functions, which are not, we do have another set of documentation. So as we said, the frame, what you get back from the streamer, and what we were working with is a NumPy array. And that's really handy because then you have all these other cool functions. So if you go to our docs, go down to tools, then image manipulation, there's a bunch of other functions that you can call that will actually manipulate or allow you to do more fun stuff with that without having to get all the coordinates, kind of as I was doing with the dot box dot start x start y. That's handy, but if you just want to resize or mark up the image with those bounding boxes, another one that Kamal mentioned earlier was that cutout image. That's how we cut out the bounding box and then passed it to the classifier. That's really handy. You can also blur objects that will blur everything within that bounding box. Well, yeah, you pass the predictions. So the next starter app or example app, sorry, that I have uses some of these guys, and it swaps people's faces using those bounding boxes. So let's do. Okay, so this guy is here, this face swapper. So you can get the URL right here, and I've already downloaded it to save a little bit of time. Okay. Should already be configured. Nope. That's got to build the environment. Okay, now there's only me, so I've just pulled up a picture on Unsplash, and you can see it's swapping our faces and it's resizing them. Pretty handy. And if you have more than 2 people, let's see if I can pull up another one. It will, sorry, trying to like do it in reverse. It will swap them off. So it would just shifts them right. That way it's not like each is a pairwise swap. It will take, you know, 1 goes to 3, 3 goes to 2, 2 goes to 1, whatever it is. So that's that one. Any questions at the moment, or should we go into the code?
I think we can go into the code. Still no questions, but that was really cool to see how it can do like more than 2 faces.
Yeah, I know it's a little weird. I really wanted to get them smoothed out, but it was just taking a little bit too long to do that. And you know, bounding boxes, that works pretty well. Okay.
But
so,
it's cool. It looked really interesting.
Good, thanks. Guys, so this one uses a bunch of the functions that are in those tools for image manipulation. So, okay, here we have, and it's a little simpler of a project layout. We have the face detector. I think that's the exact same one that was used in that first project that Kamal showed. And then we loop through and I see here I'm making a copy of the frame. That's so that you can see the original one up above and have the new frame down below. And there might have been a more simplified way to do this logic, but the logic was, okay, if it's not the first and the last, if it's somewhere in the middle, then you're going to get that one and the one above, like the next index up in your list of predictions, which is what we get when we get results.predictions, as we've done in the other apps. And then swap them. Or if it's the first one in the list, then you're going to get the one behind it. And if it's the last one on the list, you're going to swap the last one with the first one. So there might have been a more elegant way to do that. I'm sure there is. I was just in a bit of a time crunch and it worked. So that's it. And if you have any thoughts, if you do it better, please let me know. You can make comments on GitHub or make a pull request and we'll clean it up. So it's using the swap faces function, and you can see, so we're getting in each prediction, we're getting the box, and this is the original box and the new box. And then we're sending those in addition to the original frame and the new frame to this swap faces function. So first we get this, we create this face by cutting out the original face, the original box, from the original image, and then resizing it to be the width and the height of the new box from the original image. And then what we do is we index into that new image, which was a copy of the original image, and we modify that section of the original image, well, the copy of the original image, I'm sorry, using those coordinates that we saw in the last demo, the start Y and the start X plus the width of the image, and the start X and the start Y plus the Y, the height of the new image, so resizing it. And then we set that portion of the NumPy array to this new NumPy array. So you're just you have this original image and you have this new image, and you're taking the the section of the original image that corresponded to your first face, resizing it down or up to the other prediction bounding box, and then taking that new bounding box and plopping it into your new image. So I'm sorry if that wasn't clear. Are there any questions, or was that too confusing?
I think it was fine.
Okay, nice. And then you just return it. And then down here, we concatenate those two frames so that you're just sending the streamer out one image that's really the original image with the original bounding boxes. And then the new image with the face swaps and no text. I could say like, oh, swapped 5 faces or 2 faces. Probably should have done that. That would have been better. But next time I'll do that. And so if there aren't any questions at the moment, then the next thing I wanted to do was play around with some more of these the functions that you can do in EdgeIQ. Are we doing okay?
Yeah. Does anyone have any questions? We can take a pause, a breather. Yeah, I think it's really interesting to see the face swapping piece, especially because you see those filters on Instagram, you see them on like Snapchat. So it's interesting to see like how they were created, and it's cool to be able to revisit that, right?
Yeah, and if you had some sort of other image, like a static image, you could very easily, easier than this, just plop that static image using the resize function, just resize that image to be the coordinates of the bounding box of the person's face and just replace it with like a picture of a cat or some sort of, cat ears, maybe even if you had it lined up properly or something like that. Yeah.
But in terms of like development, right? Like especially like the first app that I showed where it was passing the bounding box of the face recognition and then using the AgeNet, which I think it only does the inferencing on images, right? Not
yeah, classification would take the whole image in. So I feel like I haven't tried it because it seems like it would be weird, but if you were to pass it in an image with like 5 people, I feel like it would either get very confused or just pick one. It wouldn't be able to classify it in terms of every
single person.
Yeah. So yeah, if you pair it with the object detection and just pass each cutout portion to the classifier, then you can get each one of those back. And yeah, much more, well, I guess they're like different models for different purposes, but it can be a little bit more complex that way, using them together. And, if you can use an object detector and a classifier, you can use 2 object detectors with the classifier, you can mix and match, and that's kind of cool. That's what I like about this toolkit.
Yeah, there's actually a question from Leonardo Cohen, and he's asking, can you use age recognition to classify and apply the blur face for legal reasons on minors, for example?
Yes, and that's such a great lead up to what I was going to do next, which was just blur.
Great question, by the way, Leo.
Great question. Yes, exactly. As we saw, I used it earlier and it said I was anywhere from like my actual age to 60 to 100, which is not my actual age for the record. So it depends on the model. But yeah, exactly. If the prediction, you could classify it, and if it returns out of a range that you deem too young, you can do this, which hopefully I put it in the right spot. I believe I have. Let's see. Yeah, and then you just blur it. You can still kind of tell it's me, especially with like my glasses on. But yeah, so that's a very good question. If you just wanted to blur children, or just, if you didn't want to use it with a classifier, if you just wanted to blur plants or people, or, then you can use that kind of logic in your actual application to make those decisions. That's a really good question.
Great. And then we have one from Marcos Barrera. First of all, hi, Marcos, again. And he asked, can you use transparent overlays?
Yes, yeah. Which is another function. I'm sorry, I haven't really prepared messing around with all of these today. If you guys have more, then we can definitely do it. You can try it. Yeah, so there's plenty of functions in here that have been, you can do a lot of this stuff in libraries that are compatible with Always AI, but a lot of the stuff you're probably looking for have already been written so that you don't have to worry about missing what are these called? I'm totally blanking. Missing
APIs, property.
no, but you know, variables that you pass into a function. I'm just attributes. I'm totally blanking. You know, like worrying about mismatches of types or what?
Are you looking for parameters, Lila?
Yes, thank you. Thanks, Steve. Parameters, thanks. Yeah, so a lot of this stuff has already been done. The heavy lifting has already been done, and you can know that it's compatible, that it will work. So it's a really handy document to go over.
And we've used those transparent overlays because we got tired of, you know, just the blank boxes. We can put a green background or a red background. So it was fun to do. So.
Yeah. Yeah, nice. Yeah, definitely. Yeah, and some of these have been used in like the virtual green screen and other apps we've done, not necessarily with bounding boxes, but yeah, lots of really cool stuff you can do in here. And I did have, if you guys wanted to play around with like marking up the frames with finding the key points and stuff, we can do that. Or if you have other questions,
yeah, I think that'll be cool to do some markup images.
Okay, yeah. Let's see. So I think it's in helpers. Okay, so this is just what I was talking about. The accessing the different key points. If you want to play around with plotting them and see like where they actually are, if you get confused where the origin is, or you know, X versus Y and that stuff. So let's do start. Okay, let's see. So you can see that that's where it is. And then if we want to look at the other side of things, you can see the start is up in the upper left. And the end is down in the lower right. So, I mean, if you're like me and you get a little like mixed up, X, Y, start and stop, that is one of the handy things I found. I mean, we also could mess around with some of the other functions in the library and risk me not being able to do them properly and having some sort of, you know, glitch on the YouTube. But yeah, or answer questions, whatever you guys want.
Yeah, I think we can move into questions now. Does anyone have any questions? We have about 10 more minutes left, and this is a good time to ask any questions to Lila about bounding box classes, distance measurements, applications of some of these tools.
Yeah.
Okay, hopefully while you guys are writing out these questions, I have a couple announcements. We are hosting a webinar with iCloud next week. It'll be on Wednesday. I believe the date is the 30th, and it'll be at 10:30 a.m. PDT. And we're going to be covering deployment challenges associated with computer vision. And after that, our next Hacky Hour, we will be covering facial recognition using Dlib, and that's hosted by AB. And you've probably seen AB around Hacky Hour and our webinars, but this time he's actually going to be presenting his facial recognition app, which I'm super stoked for.
Yeah, that'll be fun. That's great.
Yeah, and it's a great build up to like facial landmarking first with Steve, and then face swapping with you, and now facial recognition.
Yeah, that's a nice progression.
Yeah, it's a great progression. Okay, so Thomas Kading, he says, bootcamp student here, any takeaways that may have gone over my head? Yeah, what would you say are some major takeaways from this Hacky Hour?
Good question. Putting me on the spot. I don't know. I think I think one of the things that I always feel like that is important here is that there are a ton of resources on our site for documentation, use cases. The GitHub is full of sample apps that you can just pull and start tinkering with. I think the best way to learn any of this stuff is just by doing it. Playing around with stuff, it's very hard to I mean, a lot of the legwork is done. So I think that's one thing. If you think, oh, hey, that would be cool, look and see in the documentation or the GitHub if somebody has done it, because they probably have. And then you can build off that and save yourself a lot of time doing everything from scratch. I mean, even whenever I do a sample app, I will go back and see sample apps I've done before to save myself having to remember how to, or that configuration, that load JSON function. I always just use that instead of writing it from scratch every time. I mean, so I think that's really, in general, always AI takeaway is that it's really plug and play. You can just mix and match models and different loops. There's ways to read from a file stream, a web camera, a set of images. It's really easy, and you can learn a lot by just getting your hands dirty and diving in. And then if you have any problems or questions, you can always put them on Discord. A lot of you guys are already on Discord, and you answer questions for each other, and that's really helpful. And I think that's another way you learn the best, is answering questions from other people.
Yeah, or if you want to have a more interactive Q&A session, always, there's Hacky Hours available for you. So you can join and actually speak firsthand with our engineers, our advocates.
Yeah, you have Steve and Eric here. You can ask them really hard questions and put them on the spot.
Yeah, Steve loves that.
Yeah, who doesn't love that? Yeah.
All right. Okay, so if there's no other questions, I think we can call it an early day. But yeah, definitely join the webinar next Wednesday. I have shared the link in the chat window, so you can take a look there and then sign up. And then next week on Thursday, same time, same place, we're going to be covering facial recognition hosted by AB. So I'm super stoked for that. And yeah, just super happy to be a part of this community and excited to see the community grow and see people like Thomas interested in computer vision. And thanks, Lila, for such a great demo.
Coming, you guys. Making Hacky Hour fun.
All right. With that said, I'm going to call it a day. Have a great one, and we'll speak to you next week. Bye.